For calibration purpose, pipette 0.5, 1 or 1.5 microgram ml of working standard solution, 25 ml flask, and make 10 ml of the absorbing solution and then proceed as in the sample. These 0.5 ml will correspond to 5, 1 will correspond to 10, and 1.5 will be corresponding to 15 microgram ammonia per 25 ml. So you prepare a calibration graph. Here is the volume absorbance, here is the volume. So when concentration, when you take the sample, you may come up with the X absorbance. You find out where is the X absorbance, you draw a perpendicular and see what is the concentration here. Next. The calculation is the same as for the weight of the ammonia present in the sample divided by volume in cubic meter. Next. Next. This is the chemical method. Air containing ozone is drawn through a medicated impeller containing 10 ml of potassium iodide in a neutral solution. A neutral buffer is added to make the solution neutral. The iodine inhibitor in the absorbing reagent is determined spectrophotographically at 352 nanometers. You may need a UV photometer for this. UV visible. Next. This is the reaction for the range of sensitivity is 0.01 ppm to about 10 ppm. The sensitivity method depends on the volume of air sample. If you want to increase the sensitivity, you draw the larger volume of air. There was a question about the industrial environment, occupational environment versus ambient air quality. Here in ambient air quality, we draw a larger volume because the concentration is low. In ambient air, industrial environment, the concentration high, we use the low volume samplers. So if you increase the sampling volume, you can increase the sensitivity of the detection limits. Next. The precision is 5% plus minus deviation. Chemicals required are potassium dihydrogen phosphate, bisodium hydrogen phosphate, potassium iodide and sodium hydroxide. These are method of preparation is given here. 14 gram of potassium, 14 gram potassium dihydrogen phosphate and 14.2 gram of disodium hydrogen phosphate and 10 gram potassium iodide successively are diluted to 1 liter with distilled water, aged at room temperature for at least 1 day before use. You prepare the solution and keep it 24 hours and then use it. Measure the pH and adjust at 6.8 with sodium hydroxide to make it neutral. The absorbing solution should not be exposed to sunlight. This is a precaution. Either you use the amber color glasswares, or if it is not available, you cover the volumetric glassware with a carbon or brown paper. Next. 16 gram potassium iodide and 3.173 grams of iodine successively and dilute the mixture with distilled water to exactly 500 ml to make 0.05 normal solution. Age at room temperature for 1 day before use. This is a standard solution. Next. Pipette 10 ml of the absorbing solution in bubbler. Sample at the preset flow rate. It may depend from 0.5 to 3 liters. The flow rate and time sampling should be adjusted to obtain a sufficient large concentration. Approximately 2 microgram of ozone may be obtained in the absorbing solution at an atmospheric concentration of 0.01 ppm. So we can monitor to this level, 0.01 ppm. Next. This is a method of calibration, 0.00259 iodine solution by pipetting exactly 5 ml of the earlier prepared solution. 0.05 in sample is diluted here to have a 0.0025 in iodine solution. Normally should be checked before use. Into a 100 ml volumetric flask and dilute to the mark with absorbing solution. Prepare 4 of more standard solutions in 25 ml volumetric flask by pipetting 0.1 to 1 ml. Ideally the calibration graph is to be prepared within the expected range of the chemical pollutants produced. Immediately after preparation of the series, read the absorbance of 352 nanometer. The solution should be cover 0.1 to 1 ppm. Next. If this I already told you, significant loss of evaporation, double distilled water is to be used for makeup. Subtract the absorbance of the blank from the absorbance of the standards. When you use the blank, the reading will be higher because there is no iodine liberated. When you read the reading, there will be a reduce in the absorbance. You subtract that reading from the line of the best fit corresponding to absorbance, exactly one shall be determined. To obtain a value m representing microliter of the ozone required for 10 ml of the absorbing solution to produce an absorbance of 1, multiply this normality by the factor 1.224 into 10 to the power 3. Next. For 1 centimeter cell, m should be approximately 9.6. The result of a air sample may be computed from equation as AMB. AM is the corrected absorbance and V is the volume of air sampled in cubic meter. This is the UV absorption method. Next. This is a flow diagram. Yes, sample goes here. There is a particulate filter paper. Here is a UV source for tube, and this is the exhaust. Here is absorption cell, and this, the concentration is converted into through detector into the ozone. Next. Benzene can be collected on a charcoal filter. Next. A known volume of air is drawn through a charcoal tube to trap the organic vapors present. The charcoal in the tube is transferred to a small graduated tube and dissolved with the carbon disulfide. There are two methods. The charcoal is trapped in the benzene is trapped in the charcoal. This can be dissolved by two methods, by solution or by thermal desorption. For the thermal dissolver is not available at most of the places. So what we do, we dissolve it with the carbon disulfide. Carbon disulfide is a hazardous chemical. So it should be, enough care is to be taken just to avoid the inhalation of the fumes. The work should be done in the fume hood. After desorption, a liquid of the dissolved sample is injected into the gas chromatograph. The area resulting in the peak is determined and compared with the obtained from the injection of the standards. Next. There are some interferences are there. If the moisture is there, the moisture has got more of the organism will not be absorbed properly. So what we prepare is a small silica gel tube just to remove the water molecules before the organics are trapped into the absorption tube should have 2 or more. These are if the compound is known to have the same retention time, that will be interference, but this interference can be removed by changing the chromatographic conditions. Next. This is small sampling advantages are there. The sampling device is small, portable and involves no liquid. The tubes are analyzed by means of a quick instrumental method. The method can also be used for simultaneous analysis of number of solvents present. Next.